Welcome back to RamZland. Today we're learning about diffusion. And Rachel, can you tell me, what does diffusion mean?
It's a high concentration to a low concentration.
Oh, and it looks like, Cassandra, you've got some food coloring that you're going to measure diffusion with. And one flask looks pretty hot. I see some bubbles in there, and the other one has some ice cubes. Jalen, which one do you think will diffuse food coloring faster, the hot water or the cold water?
Hot water.
Let's find out. And Rachel, you've got a stopwatch, don't you? Okay, so you have to add the food coloring at the same time. Are you ready? Jalen, you're going to do the hot water. Cassandra's going to do the cold water in 3, 2, 1. Adam, go. Okay, let's see which one spreads out faster. Doesn't look like that cold water is doing much, is it? Rachel, how much time is clicked off? You set it for a minute, right?
45 seconds.
Okay, look at that hot water. What's that hot water doing? I would say the blue is almost fully diffused. What do you guys think?
Yeah.
Cassandra, what can you tell me about the cold water? Do you still see a high concentration of green there?
Yes.
That looks pretty highly concentrated still. It hasn't really spread out, has it? Let's look at the blue water. That's pretty even. I would say it's diffused. Good job, table 2. Let's check another table. Here we are with table 5. They're going to do their test in 3, 2, 1, go.
Come on, Gleam. Come on. You got this. Come on. Oh, gosh. I don't know.
Hot water versus cold water. Which one will diffuse food coloring faster?
Hashtag hot. Yay! It's hot.
Okay, let's look at the blue. Cold water is pretty slow. Let's look at the hot water.
It's really fast.
It is
It's the
fast.
opposite.
Okay, Cameron, how much time has gone by?
31 seconds.
31 seconds. Okay, table 1, we're ready for your diffusion test. Add your food coloring. Here we go. Here we go. Start that timer. Okay.
That's a lot. Where do I... Whoa.
Cameron, which one looks like it's diffusing faster?
Pretty much that one.
Definitely the hot water. Okay.
Maybe because it's cold and it's freezing it.
Cold water slows down molecular movement, doesn't it?
Yeah.
Those molecules move slower and diffusion is slower.
It looks like blood.
Okay, tell me about your hot water. Do you think it's diffused?
Yeah.
Okay, how much time has gone by?
29 seconds.
29 seconds. Here's table 4's diffusion test. Add your food coloring. Okay. See the hot water starting to spread out. Let's look at your cold water there.
Oh my god.
Not doing much, is it?
20 seconds has gone by.
20 seconds. Okay, Jerome, would you say that this is starting to spread out?
Yes.
Okay, how much time is on there? How much time?
We have 30 seconds.
30 seconds. Okay, and look at the ice water. Ice water is not diffused much at all. And we're here with table 3. They're going to do their diffusion test on the count of 3, 2, 1. Add your food coloring. Okay. Cold water, hot water. Still pretty concentrated there. Let's look at our hot water. Almost completely diffused there.
It's lagoon water.
It's still frozen.
Okay.
Looks like lagoon water.
All right. Table 3, do you think the green is diffused all the way?
Yes.
Okay, Jillian, how much time did it take?
30 seconds.
About 30 seconds. Okay. Good test. Here's table 6 and their diffusion test in 3, 2, 1. Let's look at your cold water over here. Yeah, pretty slow.
I think hot water.
Let's look at the hot water. Wow, look at that. Okay, how much time has gone by?
40 seconds.
Yep, I'd say it's fully diffused. Good job. Now we're going to compare our diffusion test to mechanical energy. Cameron Lee is going to add 1 drop of food coloring to water that's on our stir plate here, and you can see that it's mechanically stirred. You can see that vortex in there, and we want to see if mechanical energy will diffuse food coloring faster than heat energy. And over here, I've got Hannah with our timer. And Hannah, most of our teams had diffusion with boiling water around 30 seconds, right?
Right.
Okay, so we're going to compare this and see if we can beat 30 seconds. And Cameron, add the food coloring. Start the timer. That's good.
Dang.
No, red's actually perfect.
I still see some concentrated around the vortex. And stop.
I can't see your head.
What's our time?
1 minute, 49 seconds.
Well, we started at 2 minutes, so about 11 seconds, class. 11 seconds, we had diffusion from mechanical energy, much faster than heat energy. Now, Cameron, does someone at home stir sugar into their coffee?
Let's.
Do they stir their hot cocoa to spread it out?
My mom does all the time.
Well, this is why we stir things in our beverages, is because mechanical energy diffuses ingredients very quickly. 4th graders learning about diffusion. Nice work.